Hi, so in this video I'd like to talk about the pathlib module, which is in the Python standard library. The Jupyter notebook that is associated with this video is linked down below. It's in the GitHub repo for the blog. And basically I have the link to this here. And it is this particular module in the standard library that I want to take a look at today. So it's basically a module that allows us to deal with paths in either Windows or Linux, or what's called POSIX essentially. And what's nice about this particular module is that you don't have to worry too much about whether you're running your code on a Windows machine or a Linux machine, how you're going to define the paths, because as you know, with, let's say, Linux, you have to, you do your paths using like a /, but in Windows, you have to use a \. And if you're using a \ in a string in Python, of course, that is the escape character. So you need to use a double \ to, essentially get a single \ character. So this module is really nice in that respect. And it has kind of two separate sections. One is called the pure path. Now, the pure path is just for path manipulation. Now, what is a path? A path is basically a file system string, right? A string that represents something in the file system. Now, you can have paths that are not actually associated with something in the file system. You're just manipulating paths. You're just manipulating those strings. And that's what pure path gives you. And usually you just use pure path, and then depending on what operating system you're running on, Python is going to choose whether to get a pure Windows path or a pure POSIX path. So if I'm running on Mac, I'm going to get pure POSIX path. If you're running on Windows, when you instantiate pure path, you're going to get a pure Windows path. Now, of course, if you want to manipulate paths that are for a different operating system than the one that you're running on, you can do so with pure path. So you can directly instantiate pure Windows path from, let's say, a Mac machine, or you could instantiate pure POSIX path from a Windows machine. That would work just fine. You cannot do that with path. Path is what's considered a concrete path. This is what you actually use to interact with the file system that the application is running on. So this is concrete. This pure path is really just for path manipulation, just joining paths, extracting paths, things like that, but not actually interacting with the file system. The path does, however. So if you're running on Linux or Mac, you are going to get a POSIX path when you instantiate path. If your application is running on Windows, it's going to essentially give you a Windows path. But again, the nice thing is, you don't have to choose one of those two. You basically just use path, and Python will intelligently figure out which one is it going to use. Okay, so that's the difference between pure path and path. Now let's go ahead and dig in to paths. So let's go ahead and import it. So from pathlib, I'm going to import path. So I'm going to use a concrete path here. Now, to specify paths, we can use fully qualified or absolute paths. That's another name for a fully qualified path, as well as relative paths, where, for example, a single dot denotes the current directory, while a double dot denotes the parent directory. Now, we can get a path object to, let's say, our current path that the script is running in right now by using the CWD method. So we can say, let's say current is equal to path.cwd, current working directory. So let's go ahead and look at what that gives us. Now I'm running on a Mac, so I get a POSIX path, and this is the location of where this particular notebook is running. Now if you're running on Windows, not the WSL, you'll end up with a Windows path object. Now, a disclaimer here. I haven't used a Windows machine in probably a decade, so I'm pretty sure of what I'm saying about Windows and how things work there. But if I'm wrong, please correct me, mention that in the comments below. But everything should work pretty much the same whether you're on Linux or Windows. That's the whole idea of this module. You are going to get some differences though here and there. Now we can also use relative paths to get to our current path, right? Our current path is what? Well, we can take a look at, let's say, current 2 equals path, and then I can say, just look at dot, right? Dot means relative path, this path. That's what the single dot means. So if we do that and we look at what current 2 is, then you can see it is this particular path. It doesn't look the same as that one, right? And in fact, they're not equal to each other. Interestingly enough, if we look at that and see if they're equal, they're not, right? Because they've been defined differently. But as fully qualified paths or absolute paths, they are in fact equal, right? So let's take a look at those two. And then we'll look at the comparison between the two as well, an equality comparison. And let's say, is that equal to current 2 dot absolute? So as you can see now from an absolute perspective, those are both the same path. And in fact, they do turn out to be equal. So that's one way of checking if two paths are the same or not. Now, another way to do that would be to use the same file method. So we could look at, let's say, the current directory and say, is it the same file? Now, just a word here about why is it same file, why not same path? Well, you have to think that a path could be a path to a file or a directory, right? Those are both valid paths. Now, in fact, in various operating systems, you could have paths to other things as well than just files. For example, in Linux, and I think Windows as well, you can have symlinks, and those eventually point to something else. But in Linux, for example, you could also have paths that are pointing to maybe sockets or block devices and so on. And we'll take a look at some of that in the context of when we check if something is a file or is a directory. I'll show you the documentation for the other stuff. So we can use same file method to check if two paths are pointing to the same thing, whether it's a file, a directory, a block device, it doesn't matter. It's still called the same file method. So if we do that, we get that that's true. Now in both Windows and POSIX, you have the concept of a home directory, which we can obtain using the home function. So if you want to, let's say, do some path work, some manipulation of files or directories based on the current user's home directory, you don't have to try and, build the path up and so on. You just use this home method and you get that. Now, in my case, I'm on a Mac and my home directory is indeed users/fbaptiste. All right, so let's go ahead and experiment with files and paths and so on using this concrete path. I'm going to create a file just in the local directory where I'm working. So I'm going to say with open, let's call it test.txt. And we're going to make this a writable file. And of course, we will use the with. And let me finish writing the code. So we'll do f.write and let's just write some code. Testing the Python path object. Something like that. Okay. So now I've used the context for opening the file, written the file, and when the context exits, then the file is closed. So this file has been created. Now let's go ahead and get a path object for this file. So I'm going to say file equals path, and we'll just look at the test.txt file. And if we look at what is contained in file, you can see that we have this POSIX path test.txt. Now if I need to, I can get the absolute path, right? So the fully qualified path. So that's there. As you can see, I'm in my home directory, and then I have a subdirectory called dev. Then I've got another one, Python blog, and my file is actually in that root of my blog. Now we can use the stat method to get some meta information about this file. So let's go ahead and say file stat is equal to file.stat. And that has a bunch of properties. And I'm only going to pick one or two of those. So because some of the information is going to be platform dependent, but at least the two things that we can use across both Linux and Windows that I know of. One is the size, which is this st size. This is the size of the file in bytes. And then we also have the modified time, this m time, stm time for modified time, which, by the way, is a POSIX timestamp, right? It's not given as a Python date time object. So we can get the file size by saying file size.st_size. That'll give us the file size in bytes. And then we can also look at the file stat.modified time. So st modified time, like so. And this is actually a POSIX, so a POSIX time. So we can actually convert that to a date time. We could just have to import from date time. We'll import date time. And then we just use the from timestamp, right? So we can say date time from timestamp. So this one here. And then we can pass it this file stat.stm time. And then we get a date time back. Now, one thing that's very important to note is that this epoch time, this POSIX time that you get here, is reported back in local time. So this is the local time on this machine when this file was last modified. Right? So for me, it's, I created this about 4 minutes ago. It's 9:15 in the evening for me. And you can see it's 9:11 p.m. So this is very important for you to realize. This is a local time. If you want it in UTC, you're going to have to convert it to UTC. So you can find more information about these different statistics, this different metadata essentially that we have around files. I have the link in the notebook. But basically here you can look at things like the mode, this INO, dev, and you can see that we have the size, which is the size of the file in bytes, if it's a regular file or a symlink. And then we also have things like mtime, the most recent content modification, right? Then you've got time of access, most recent access, and a few other things as well. And as I said, some of them will be dependent on the operating system. Okay, so this is how we can basically get a path to a file in this case, but it could also be to a directory. Now, we also sometimes want to test if a file or a path, and really I'm going to stick now to just files and paths, so and directories basically. I might be interested in knowing if it exists. So again, this is a concrete operation, right? So far, these have all been concrete operations. We want to look at a specific real file in the file system. Now I want to check if something really exists in the file system or not. So I know that I just created this file, called test.txt. So I can look at that and we can look at the exists method. And so this tells us true, that it exists. In fact, if I was to do a different file, which I know that doesn't exist, I would get a false over here. Okay, so some simple methods so far. Now you probably know, and I mentioned at the beginning of the video, but the way that you do path definitions in Windows and POSIX or Mac, Linux, and those kinds of Unix-based systems are quite different. For example, Windows uses the backslash as a path delimiter. POSIX uses the /. You have drive letters in Windows. You don't have that in POSIX. So one difficulty when you're dealing with paths and manipulating paths is, well, what should I use? Should I use a /, a backslash? Because if I'm on Windows, I need to use, the backslash. If I'm on a Mac, I need to use the /, and you end up writing if statements to try and figure out, your path manipulations, etc. Essentially, right? To bifurcate your path definitions. With the pathlib module, you don't need to do that at all. Basically, you use the POSIX standard. We do not use the backslash, which is great because remember that in Python, if you use a backslash, right? If I do a \n, well, that is actually an escape character. So if I was to write something like this, ABC \n DEF, So if I just do the representation, I still see the escape character. But if I print it like so, then that goes and disappears, right? We'll actually see now the escape character embedded now in our output. So so the pathlib basically saves us from having to, if you were going to do a path definition in Windows like so, like let's say C:\\, well, the backslash, that's the escape character, so I have to escape it. So I have to do a double backslash. And I might have directory 1 \\\, to escape it, directory 2, and so on, right? Now, if you print it, and if you were to write the string out to a file or something, you wouldn't see the double backslash because that would be escaped. So like so, right? You would actually get this. So this over here is how we would have to write a Windows path. So that's a little bit tedious, if we're using Python to have to do that all the time. So for both Windows and POSIX, we can define a path this way. We can say, let's say I'm going to take the current path, and then I'm going to use the /dir1/dir2. So if I do that, I get my POSIX path, because why POSIX path? Well, because I'm on a Mac, right? Now in Windows, you'll get a Windows path. But the interesting thing is that you will be able to use the /. You do not have to use the backslash. Now, you have drive letters, so you're still going to have to do something like this, like C:\. Now, you don't use the backslash, you use the /. So we'll do that, directory 1/directory 2. You would still do this. This is perfectly fine, and you will get the proper path on your Windows machine. Okay, so basically this means that in terms of the rest of this video, I'm just going to use POSIX path definitions. I don't have to worry about backslashes anymore and the slight differences with Windows. So I'm just going to continue now. Since I'm using a Mac, I'm going to be using POSIX paths, but pretty much everything that we talk about here, it's going to work the same on Windows. So let's continue now with the exists example, because I'm not finished with that yet. So let's say that we go ahead and take this path over here. So this is my home path, like so. And I want to know, does it exist? So I can just say exist, right? We've seen that before. If I take something that doesn't exist, let's say that, I get a false, okay? So given a path, you can not only test if it exists or not, as we just saw, but you can also determine if it is a file path or a directory path using the isdir and isFile methods. And those are all documented in here. So let me do a search for isFile. So here, right? So we have some things to check what type of path we're dealing with. Is it a directory? Is it a file? Is it a mount point? Is it a symlink? And again, some of these things are going to be specific for, Unix or POSIX. Is it a socket, for example, and so on. So there's a few available here. In this video, I'm just going to focus on directories and files, but just be aware that depending on your operating system, a path may be pointing to some other resource on your machine other than just a directory or a file. So we can use these methods, isFile, isdir, to check the existence of files and paths and directories. But you got to be careful, right? Because those will return false if the path does not exist. So let me show you that. So if we do test.txt isdir, and we do this one here, path test.txt. So I know that that file exists, right? We just created it just a little while back. So is it a directory? Is it a file? I know that it exists, right? We did it earlier when I showed you when we were looking at the file. And that is therefore false because that is not a directory. On the other hand, it is a file, so that came back true. Now, if we look at, let's say, a directory, then we can do something similar. I'm just going to take, let's say, /users, which I know exists on my machine. And you can see that directory now in this case is true, but file is false. Now, as I said before, there's other things than just directories and paths in the operating system. So just because something is not a directory, if directory comes back as false, it doesn't mean that you're dealing with a file necessarily. Okay, but even if you know that the path is going to be either a directory or a file, you've got to be careful, because if the path does not exist concretely on your operating system, these methods will return false. So if I was to go ahead and take, let's say, test.txt, and I look at test2.txt, I know that that does not exist. And so what I get is that both isdir and isFile is false. Both are false, even though this would technically be considered a file from an abstract perspective, from a non-concrete perspective. So be careful with that. So usually we're going to use like exists and then something else. So first check, does it exist? And if it does exist, then okay, is it a file? Yes or no, right? As opposed to, is it a file? No. Well, maybe it's because it doesn't exist yet, okay? So one of the ways that you've seen me doing paths is by essentially specifying them like that inside a string. But we don't have to do that. If you don't want to deal with that, you could go ahead and use the join path method. So that can be useful as well. So we can say p equals path. And let's say I'm going to start with users, and then I'm going to join path. And then on the path, I'm going to specify a few things. I'm going to say, I want directory 1, I want directory 2, and I want, let's say, directory 3. And you could even throw in, let's say, a test.txt if you wanted. So now that I have this path, you can see that it was properly created. So we can use this join path, and you can pass an arbitrary number of arguments. So that's the nice thing, right? As you're developing code, you may have your path broken out into its components in a list, and you want to put them back together into an actual path. You can just basically call the join path method, and then you can basically expand that, right? So we can, let's say that I've got my path bounce. Let's call it bounce equals like so, right? So we'll do this. Then all I need to do is just say path, specify some root. So let's say users, and then I'm going to say join path, and I can just pass it the star bounce, right? So I can expand bounce essentially, and I get the same result as before over here. You can also, instead of using, so this is useful, right? If you're going to have something that's programmatically building your path up. Now, if you're just typing it in, you can certainly do it this way, like we did over here. But what's interesting is that the actual division operator, the slash operator, actually supports joining paths. So let's go ahead and take a look at that. So this is kind of cool. So you can say path.home. Remember, that's going to be my home directory. And I want that home directory /dir1 /dir2 /tst.txt, right? I'm not going to put dir3, but basically I want that. Almost what I had before. Well, I could certainly, do some string manipulation here. I could convert home to a string, or I could even say from that point here, I could say join path, right? I could say join path and then dir1 and then dir2 like so, and then tst.txt, for example, right? So I could do that, but an easier, cleaner way is actually to say this, path home /dir1 /dir2 /tst.txt. And it doesn't have to be all strings. It could be paths as well. You could say path, let's say it was path, dir2. Let's say it was a path object as opposed to just a string. That works equally well. And you can see we get the same result. So that's how we can combine paths. We have different ways of combining and manipulating our paths. And of course, these kind of path manipulations can work as pure paths as well, since they don't rely on the existence of those things, right, in the actual file system. Now, the exists and the isdir and isFile, of course, that is a concrete kind of application. Now, the opposite of combining paths is, of course, to decompose a path into its individual parts. Again, something that we do fairly frequently. So if we look at P, we can look at its parts. So if you've got a path object, then you can look at its parts. And this, of course, applies to either concrete or pure paths. So if we do that, you can see that basically we get a tuple back that has the root, right? This is the root of my file system, then users, then my user directory, inside users, then directory 1, then directory 2, and then the file finally. Now for a Windows path, if I want to manipulate Windows paths, I'm on a Mac, but I can still do it as long as I'm not looking at concrete methods. So I can do a pure path. So I can say from pathlib, I'm going to import specifically pure Windows path, right? So I just want to show you that it kind of works the same way in cases where we're dealing with a pure path. So let's call it Windows P is equal to pure Windows path. And here I'm going to use the POSIX style of defining paths, even though this is for Windows, right? And then I'm going to say dir1 and then dir2 and test.txt, okay? And of course, if you are running on Windows, then what we just did over here, you would have ended up with a Windows path anyway, right? But here I'm running on a Mac, so if I want to deal with Windows kind of paths, then I have to use the pure Windows path explicitly. So let's take a look at what that is and what did I do wrong? Oh, that like so, sorry. Okay, and as you can see now, I get my Windows directory, right? C:/dir1. Now that's the POSIX style. Now, if I wanted to actually see the actual Windows path in the Windows style of defining a path, I can just look at the string representation, right? And so you can see here I've got the C:/\/. Of course, this is because this is an escape character. If you don't want to see the escape characters explicitly, you actually want to see them rendered, then you can do that. And of course, now you have what looks like a real Windows path. So parts gives us this breakdown, right? So even though this is a Windows path, I can also say Windows p.parts, right? That will work the same way. You can see we've got the drive letter. Again, don't get confused by this double slash. It's an escape character, right? So we've got C:// as the drive. Then we've got the folders, and then we have the file. Now, related to this, we can look at the logical ancestors of a path as a sequence, right? It's kind of this is already kind of a sequence, but it's breaking the path up. But if you think about it in terms of ancestors, if we look at this file is contained in C:/dir1/dir2, right? And dir2 is itself contained within C:/dir1, and then dir1 is contained in C:/. So there's an ancestry of those things, right? Where essentially you'd be taking this, and then this, and then this, and then this, right? That's the hierarchy in the file system. And we can do that, we can look at that using the parents property. So let me go ahead and do it this way. So for idx, parent in enumerate, I'm going to enumerate p.parent. So now I'm going back to my Mac, my Linux, essentially my POSIX path that I have. And here I'm going to print an F string, and I'm going to print, let's say, the ID. So this is just to have essentially a loop counter. And then we're going to print out the parent itself. So when I do that, you can see what's going on, right? So my path, my P was what? Let's just go ahead and print it out here. It was users fbaptiste dir1 dir2 test.txt. So if we look at the parents, well, the first parent is this over here. Then the parent of that is this one over here. And that parent is this one. And that one's parent is this. And that one's parent is the root. And of course, you'll get the same thing with the Windows paths. So same deal. I'll just show you here. If we look at P, we called it Windows _ P. You get the same thing, right? So we had dir1, dir2, then dir1, and then the drive letter. Now, if you're only interested in the immediate parent, then instead of using parent, you can use the singular. So you can say p.parent. So this is fairly common to use, as well as it works the same way on Windows. And again, I can manipulate all these paths, right? Whether they're Windows paths or POSIX paths here, because in this case, even though I'm running on a Mac, these are not concrete classes, right? These are not concrete paths, they're pure paths. You can also recover the last part of the path. That's also quite, useful and used very often. And if we look at P again, right? And so I want the last part of this path. I want this. Now, be careful. It doesn't mean always it's going to be a file name, right? But in this case, it is going to be a file name, right? So I've got p.name. Now, if there is a suffix to the final component of this path, then you can use the suffix to get it. So if we look at suffix, we'll get the .txt. Now, if we deal with a directory path instead, let's say this. Let's say we have path.home, and then we'll say dir1. Okay? So this is my directory. So I've got a concrete path now, even though this actually doesn't exist. That's perfectly fine, right? It doesn't exist, but I can still manipulate that path. That's not a problem. So I can look at the name, right, of that. And so the name is now directory 1. It's not a file, right? Here, the name, which is essentially the last component of the path, was the file. Here, it's actually the directory. And of course, if I look now at the suffix, well, there is no suffix here. So I get a blank string back for suffix. So there are many, many more methods to manipulate paths and analyze paths. So take a look at the documentation in pathlib, and just, as you can see, there's a lot of it. Just remember that there are lots of things you can work with in paths that don't require concrete paths, where you can just use a pure path. But in cases where you do want to actually interact with the file system, because you want to know if a path exists or not, or you want to create one and so on, then you have to use a concrete path. All right, let's actually now look at some concrete methods in more detail. So one thing that we can do is we can use the open function so far, and probably that's how a lot of you have been using the open function in Python or the open context manager. You just pass in a string that contains the path to the file that you want to open, right? Whether it's for reading or writing. So we've probably, done like this. And actually we did that earlier in this video. So we'll say test.txt as f, and then print f.readlines. Okay, so we're just going to read the file and just print out what's in there. As you can see, testing the Python path object, that's what we wrote. So here's how we specified the file that we wanted to open. But instead, I might have a path object pointing to that file. I might say path.cwd, right, my current working directory, and then I'm going to basically use test.txt. So I'm building my path this way in this case, right? So if I look at that, this is what I have. Well, I can use that as well. So I'm just going to copy paste so I don't have to retype. Typing and talking at the same time is not easy. So I'm going to open my path here like so, and it's going to work exactly the same way, right? So you can pass a path object to the open function. Now we can also create and delete directories from within Python. So again, let's go ahead and say path, p equals path.cwd. And this time I'm going to want to create a directory called dir1. And I'm going to check first to see if it exists, okay? And it does not exist. But we can create it. I can say p.makeDirectory, mkdir. If you're used to the Linux command line, that's exactly what we're getting here. Okay, mkdir, we're making a directory. And if we do that, and then we check if it exists, you can see that it does indeed exist now. It was actually created on my file system. Now, if you try to create this directory again, so if you try and create a directory that already exists, then you're going to run into problems. Python will basically give you an exception. So if we try and create it again, then we're going to get a file exists error. And then we can just go ahead and print the error, the exception. As you can see, it tells us the file already exists. Now you can delete a directory or delete a file. And to delete a directory, you can use rmdir, but it only works if the directory is empty. So we can go ahead and say now p.rmdir. And then once we do that, we can check whether it exists or not. And so it was deleted and it no longer exists. Now, of course, if you try and do that, if you try it again, so let's try and say p.rm directory, so remove directory, then Python is going to raise an exception. It's going to raise the file not found exception in this case, the file not found error as ex, and we'll just print ex. As you can see, it tells us that there's no such file or directory. So if you try and create a directory that exists already, you get the file exists error. If you try and remove a directory that doesn't exist, you get the file not found error. And again, just note it will only work on empty directories. Now, the mkdir method also allows you to create not just a single directory at a time, but if you pass it a path, it can actually create all the directories along that path as needed, but it's not the default behavior. So let me show you what I mean by this. So again, I'm going to start at my current working directory, and I'm going to tag on dir1, which I know at this point doesn't exist, right? We just deleted it. But I also want within that directory 2, and within that, I want directory 3. So this is the structure that I want to create. And so, you might think that, well, you got to create directory 1 first, then you have to create directory 2 within directory 1, then you create directory 3 within directory 2. And in fact, if we try and do this p.mk directory, so make the directory, well, we get a file not found error. And it's telling us that, well, this thing doesn't exist. Well, that's right. It's trying to basically create directory 3 inside directory 2, while directory 2 doesn't exist. And so this is why we're getting this exception. So by default, that's not going to work. What we can do, however, we can say p.mk directory, and we can specify the option parents equals true. So just pass the named argument parents equals true. When you do that, you can see no exception. And in fact, now, if we look at, let's say, we'll say path.current working directory /dir1, and I'm going to test, does that exist? And the answer is yes. So that was created. If I add directory 2 to that, yes, that was indeed created as well. And then the same thing with directory 3, right? Those all exist. They were all created. Now, in order to delete the directories, however, I cannot just delete directory 1. I have to delete directory 3 first, then directory 2, then directory 1. Because again, the remove directory, it's kind of dangerous, right? So it's a good thing that Python is going to stop us from deleting a directory if it's not empty. And if you do try to do that, if you say, let's say path.cwd.join path, I'm just using a different way of joining paths here, right? Just to get some exercise, get some practice with it. So I know directory 1 contains directory 2, which contains directory 3. If I try and remove that, then I'm going to get this OS error. And it's going to tell us that the directory was not empty. And if you're tempted to write code to basically empty directories recursively, just like you have the rm -rf flag in Linux, you can. And I've done it, of course, but be very careful. It's very easy in this case to start deleting things that you did not want to delete. especially, since you're probably running your Python applications as, yourself. And so if you are, you most likely have enough admin rights on your machine that you could do quite a bit of damage if you're not careful. So I'm not going to do this here. Now we sometimes want to iterate or get a list of all the paths contained in some path in a concrete sense. And that is that, we want Python to examine the file system to come up with that list. So for that, there's a few ways that we can do that. The first one is we can use the iter_dir generator method. So let me go ahead and show you that. So root equals path.current working directory. So again, I'm going to start there. And I'm going to go to the parent of my path, for example. Actually, I'm not going to do that. I'm going to set my root directory equal to path.cwd. So I'm just going to take my current directory, which is my blog directory. If I go beyond that, I'm going to, basically be listing way too much out that I don't want to show in videos necessarily. It's got all my dev folders. So if we look at that, you can see that this is our path. I'm in this Python blog, and of course it exists since I'm in that particular directory. So now what I can do, I can use the iter_dir, which is a generator. So I'm going to have to iterate through things. So I can say for path in root.iter_dir, and then I'm just going to print the path. So of course these are all going to be path objects, right? They're going to be concrete paths. And you can see that we have this directory here. I've got this current file, which is actually the one that we're editing right now. There's a bunch of stuff with, some hidden files and Git stuff and directories that we just created and so on. So basically it's a way to iterate, all the paths inside a particular directory. You can use iter_dir. Now, I may be interested only in the subdirectories. I don't want to see the files. I just want to see the subdirectories. In which case, we can easily filter directories out. We can use a filter function, to keep the generator aspect. Or if you're not interested in that and you just want to actually get a full list of it, then you can just use list comprehension as well. Or you can even just use an if statement inside a loop. So in this case, I might modify this statement to say if item.is directory. So if it's a directory, then go ahead and print it. And that would be path, sorry. So you can see now it's only giving me the directories. Yes, .git, .idea, .ipynb checkpoints are directories in my system. If you wanted to get the, use the list comprehension, you could say item for item in root.iter_dir and then just put a filter if item.is_dir, like so. And you'd get essentially the same thing, but as a list. And if you want to keep a generator, you could say that your paths, let's say, is equal to filter. And then now we can use a lambda function to filter. And then we'll say take the item and only keep it if item is dir, like so. And then we'll pass it the root.iter_dir, right? So we're going to pass it that generator. We're going to basically keep a generator. Paths is going to be still a generator function. And so now at this point, I could go ahead and iterate through that, or of course, I could even make a list out of it. And we would get the same thing. Now the iter_dir method is not recursive, right? It didn't go ahead and recurse and find everything under that directory and so on. So if you want to make it recursive, you're going to have to write your own recursive code. But for that specific scenario, Python gives us another method, and this is the last one I'm going to cover here in this video, but it's probably one of the most important methods in this library when you want to find things in the file system. It's the glob method. And it's an incredibly useful method that recursively or not will find and will list paths that match a specific pattern starting at some root. Now, the pattern is not regex. Right? Let me just say that right off the bat. The patterns are relatively simple patterns, and they're mainly used as inclusion patterns. What do you want to include in this glob? not what do you want to exclude. There is some ability to exclude things from globbing, but it's not very powerful. And so what you probably will end up doing is using globbing with inclusive kind of filters to say, give me everything that matches this. And then after that, you can filter out what you don't need. And for that, then at that point, you could use regex or some other mechanism too. So let's say that I want to see all the files in my current project that end with a .py. So again, I'm just going to go ahead and I have my root, right? And if I look at my root, basically I'm in the Python blog folder. So now I want to list all the Python files in here. So I'm going to say for path in root.glob, and then I'm going to tell it I want everything with a .py extension, okay? And then we'll just go ahead and print the path. Now, of course, these are going to be path objects. And I don't have anything in there, right? If we go back and look at what I had, I think when I did the full listing, which was, where did I have the full listing? Oh, because I modified this, right? So let me remove that. And so you can see that I have like a readme.md, test.txt, but I don't have any Python files. So I could, of course, if I wanted to show you, right, if I do the md, it's going to find that particular file. Let's go back to py though. So it doesn't find anything in there. But it's not recursive. As you can see, it didn't find any Python files. And believe me, there are Python files in this Python blog. Now, you can see the standard path name pattern matching possibilities. I have the link in the notebook, and it's this one here. And if you look at this function match, then you can see what the patterns mean. So a star means match everything. A question mark says match a single character. If you put square brackets, you can match any character in the sequence. And this is where you can also filter things out by putting an exclamation point. Typically though, I tend to use the first two and occasionally the last one, but mainly the first two, depending on what I'm trying to do. And if I want, a more refined way of filtering things, then I will do it after the globbing is finished. So this was basically the pattern matching. But how do I tell now this globbing that I want to do it recursively? Well, it's very simple. You use a double star. So let me copy paste that so we'll see the two side by side. But you use a **/*. That's all you need to do. Once you do that, you're basically telling glob, I want this to be recursive. And then it's going to start from wherever the current directory is, because I haven't told it otherwise. And it's going to basically look for all the .py files. So now if I run that, you can see now there's a whole lot more going on, okay? And of course I can use the star multiple times, right? So for example, this is only returning things that end with exactly py. But I could say, well, I want something that where the name, right, the last part of the path ends with, or contains .py and then anything else after that. I don't care. So any part of the path essentially that contains, any path that contains .py in it, right? Essentially, that's what this is saying. So when we do that, you'll see that I have other things coming up too. Now I've got this PyC for the PyCache. I should have some notebooks as well. Oh no, because the notebooks would be IPYNB, right? So now if I do this, for example, now I'm just saying just take anything with, a dot, anything that has a dot and then a py inside that extension. And so if I do that, now you can see I've got the IPython notebooks as well. All right, so that's it for the pathlib. There's a lot more to this library. I spent quite a bit of time on it because it is very, very, very useful depending on the kind of work that you're doing, and it's often overlooked. All right, thanks for watching.